Welcome to Power Electronics tutorials. In this tutorial, we are going to discuss about working of SCR, that is working of silicon control rectifier. This is very simple and very easy concept. These are the main outcomes from this tutorial. That is, in this we are going to discuss about what is SCR and what is the construction and electrical symbol of SCR and what is the working of SCR and what are the advantages and what are the disadvantages of SCR. Coming to what is SCR, SCR is a silicon control rectifier. It is the example for control on and uncontrol off power semiconductor device, and it is also known as Thyristor. Coming to construction, it is a 4-layer, 3-terminal, 3-junction power semiconductor device. This is the construction of SCR and these two are the electrical symbols of SCR. Here these are the 4 layers, that is P, N, P, N. These are the 4 layers and these are the 3 terminals, that is this is 1 terminal and this is 2nd terminal and this is the 3rd terminal. The terminal which is connected to upper P layer, is called anode, and the terminal which is connected to lower N layer is called cathode, and terminal which is connected to lower P layer is called gate. And these are the 3 junctions, that is J1, J2 and J3. These are the 3 junctions. So it is a 4-layer, 3-terminal, 3-junction power semiconductor device, and these two are the electrical symbols for SCR. That is same as the diode construction is like this. Okay, diode having 2 terminals, that is only anode and cathode. Coming to SCR having one more extra terminal, that is the gate. This gate terminal may be connected like this or we can connect like this. Okay, these are the same, these two electrical symbols are same, we can use any one symbol. This is about construction and electrical symbol of SCR. Coming to working of SCR, the working of SCR can be explained in 3 operating modes. Those are, first one is the reverse blocking mode, second one is forward blocking mode, third one is the forward conducting mode. Now we are going to discuss about what is the behavior of SCR in these 3 operating modes. That is, concept is very simple. Coming to first operating mode, that is reverse blocking mode. In reverse blocking mode, we are going to apply the negative voltage across anode and cathode. That is nothing but anode is negative and cathode is positive. And we know in P layer the majority charge carriers are holes. That is positive charge carriers. In N layer the majority charge carriers are electrons. That is negative charge carriers. Similarly in P layer positive, that is nothing but holes, and in layer negative, that is electrons. Now we are going to find out the behavior of these 3 junctions. That is, due to the positive charge carriers and anode is negative, so there is a attractive force between these 2 charge carriers, means holes which are present in the P layer moving upwards. Similarly, these are the electrons and these are the holes. So there is an attractive force between these 2 charge carriers. Similarly, N layer having the negative and cathode is the positive. There is an attractive force between these 2 charge carriers. Means electrons which are present in the N layer going to move downwards. Now, if we observe the width of junction J1, the width of junction J1 is increases. Why? Because holes are moving upwards and electrons are moving downwards. So width of junction J1 is increases. The width is increases means it does not allow the flowing of current through this junction. So junction J1 is in reverse bias, which is act as a open circuit. Similarly here electrons in N layer and holes in P layer gets attracted. So the width of junction J2 is decreases, which is comes into forward bias, act as a short circuit. Similarly, the width of junction J3 is increases, which is in reverse bias and act as a open circuit. Due to the open circuit of junction J1 and junction J3, there is no possibility of moving the current from cathode to anode. But there is a possibility for small reverse leakage current of the order of nanoamperes, which is moves from cathode to anode. In this case, SCR act as a open switch. SCR act as a open switch. That is the first operating mode, that is reverse blocking mode. Coming to second operating mode, that is forward blocking mode. In this mode, we are going to apply the positive voltage between anode and cathode. In previous case, we applied the negative voltage between anode and cathode. But in this case, we are going to apply the positive voltage between anode and cathode. That is, anode is positive and cathode is negative. We already know these layers, that is P layer having the majority charge carriers are holes, and this N layer having the majority charge carriers are electrons. Again P layer are holes, N layer having the majority charge carriers are electrons. Now we are going to analyze the behavior of these three junctions. Depending upon the behavior of these three junctions, we can conclude that SCR is in open switch or closed switch. Now here anode is positive and this P layer having the electron, that is holes are the majority charge carriers, means these two are the same charges. So there is a repulsive force between these two charge carriers, means holes which are present in this P layer trying to move downwards, means trying to cross the junction J1, and electrons which are present in this N layer attracted by these holes, means these electrons trying to cross the junction J1. So the width of junction J1 is decreases and junction J1 comes into forward bias and act as a short circuit. Similarly, this layer, this P layer having the majority charge carriers are holes, and here electrons, the electrons in this layer going to attracted by these holes. So here these holes going to attracted by these electrons. Why? Because here cathode having the negative polarity. So there is a repulsive force between this negative polarity and these negative charges. So these electrons going to attracted by these holes. So junction J3, the width of junction J3 also decreases and it comes into forward bias, which is act as a short circuit. Now coming to junction J2, here electrons are moving upwards and holes are moving downwards. So the width of junction J2 is increases. The width of junction J2 is increases, which does not allow the flowing of current through this junction. So junction J2 is in reverse bias, which is act as a open circuit. Here junctions J1 and junctions J3 are in forward bias, but junction J2 is in reverse bias. Due to this reverse biased junction, there is no possibility for current for moving from anode to cathode. But due to the minority charge carriers, small amount of forward leakage current of the order of microamperes can flows from anode to cathode. In this case also SCR act as a open switch. This is the second operating mode, that is forward blocking mode. Coming to third operating mode, that is forward conducting mode. In this mode also we are going to apply the positive voltage across anode and cathode. That is nothing but anode is positive and cathode is negative. Same as second operating mode, that is forward blocking mode. Due to the application of positive voltage across anode and cathode. Junctions J1 and J3 are in forward bias, which are act as a short circuit. Now we are going to concentrate on junction J2, that is the width of junction J2. In this case, we are going to increase the voltage between anode and cathode, or by keeping the voltage between anode and cathode is constant by using some external voltage source which is connected to gate terminal. We are going to inject the charge carriers at junction J2. At particular value of external voltage, the width of junction J2 is going to decrease, and at particular voltage value, junction J2, the width of junction J2 is decreases, and finally it comes into forward bias, which is act as a short circuit. Here all three junctions act as a short circuit which are in forward bias. So there is a possibility of current which is flows from anode to cathode. Means in this case SCR act as a closed switch and allows the large amount of current from anode to cathode. That is the behavior of SCR in third operating mode, that is forward conducting mode. That is in first operating mode, that is reverse blocking mode, SCR act as a open switch and it allows the very small reverse leakage current of the order of nanoseconds. In second operating mode, that is forward blocking mode, in this mode also SCR act as a open switch which allows the small amount of forward leakage current of the order of microamperes. But in third case, SCR act as a closed switch and it allows the large amount of current from anode to cathode. This is the three operating modes of working of SCR. Coming to advantages of SCR, SCR having so many advantages, but these are the important advantages of SCR. That is, first one is the SCR can block high amount of voltages. That is, single SCR can block up to the voltage of 10 kilovolts. And second one is the SCR can allows the high amount of currents, means single SCR can allows the current up to 1 kilo amperes. Here voltage and current ratings are more, so the lifetime of SCR is large. And SCR is a fast acting switch, means within fraction of seconds SCR can turn on and turn off. And SCR can withstand, means the operating frequency of SCR is very high, that is up to 10 kHz SCR can withstand or SCR can operate. These are the some of the advantages of SCR. Coming to disadvantages of SCR, even though SCR having so many advantages, it having some disadvantages. In that first one is the forward voltage drop across the SCR is 1 to 2 volts, means when SCR is in conducting state, the voltage drop across that SCR is 1 to 2 volts. If we consider diode, the forward voltage drop across the diode is 0.3 to 1 volt. So this is one of the disadvantages of SCR. And coming to second one, it requires the forced commutation for turning off the SCR. Here commutation is nothing but the process of turning off the SCR is nothing but commutation. It requires the forced commutation, that is nothing but it requires external circuit for turning off the SCR. Why? Because SCR is the example for control on and uncontrolled off. For turning off the SCR, we require some external circuit. We are using external circuit, means the cost of the turning off process is more. So these two are the major disadvantages of SCR. In the next tutorial, we are going to discuss about characteristics of SCR. That is, what is the use of finding the characteristics of SCR and what are the different types of characteristics. Thank you.